This question comes from Marcus, who asks, what if all the oxygen on Earth suddenly doubled, but only for 5 minutes? My question for Marcus, do we at least get a warning, or is this just a surprise upgrade to the atmosphere? Because on the surface this sounds amazing. More oxygen, better breathing, maybe you feel stronger, sharper, like you just unlocked some kind of human performance boost. But oxygen is one of those things that sounds harmless, right up until it isn't. Let's start at the very beginning. Right now, Earth's atmosphere is about 21% oxygen. If that suddenly doubled, we'd jump to roughly 42%. And that doesn't just make the air richer, it makes it dangerously reactive. Because oxygen doesn't just help things live, it helps things burn. Now imagine it's a normal day. You're walking outside. Cars are moving. People are talking. Nothing feels unusual. Then, without warning, the oxygen level doubles. At first, you might actually feel better. Your lungs pull in more oxygen with every breath. Your blood oxygen levels rise. Some people might feel slightly energized, a little lightheaded maybe, like taking a very deep breath after being underwater. For the first few seconds, it almost feels like an upgrade. But then the chemistry starts to matter, because combustion depends heavily on oxygen concentration. And at 42% oxygen, things that normally don't catch fire suddenly can. Within seconds, small ignition sources become dangerous. A cigarette, a spark from a power line, static electricity, even a hot engine, things that would normally smolder, now ignite. Fires don't just start easier, they burn hotter, faster, more aggressively. Flames spread in ways they never would under normal conditions. Materials that are usually considered safe become fuel. Clothes, furniture, dry leaves, even some metals under the right conditions. A small flame doesn't stay small for long. Now we're about 30 seconds in. Across cities, scattered fires begin appearing. Nothing coordinated, just random ignition points. But in an oxygen-rich environment, randomness is enough. Firefighters would be overwhelmed almost instantly. Because this isn't one fire, it's thousands, and they're feeding on air itself. Now let's talk about the human body again. Because oxygen isn't just helpful in higher amounts, it can become toxic. At very high concentrations, oxygen starts damaging tissues, particularly the lungs and the central nervous system. This is known as oxygen toxicity. Divers experience this under high-pressure conditions. But even at normal pressure, 42% oxygen is pushing into uncomfortable territory. After a minute or two, some people might start feeling symptoms: coughing, chest tightness, irritation in the lungs. In extreme cases, dizziness or visual disturbances. Not everyone would be affected immediately, but the risk would be there. Now we're 1 minute in. Fires are spreading, air quality is deteriorating in affected areas, and the oxygen itself is making everything worse. Because the more things burn, the more heat gets released, and the faster new fires ignite. It's a feedback loop. Now let's zoom out. Because forests don't need much encouragement to burn. Under normal conditions, wildfires can already spread quickly. Now imagine forests in 42% oxygen. Flames would move faster, jump further, burn hotter. Entire regions could ignite in a very short period of time. And remember, we're only a couple of minutes into this 5-minute window. Now here's where it gets even more interesting. Because not everything reacts immediately. Some materials would begin slowly oxidizing at higher rates. Rubber, certain plastics, organic materials, even things like paint or oils. Over time, these materials could heat up internally, and in some cases, spontaneously ignite. So even places without an initial spark could become fire risks. Now we're approaching the 3-minute mark. The planet is not on fire everywhere, but it doesn't need to be. It only takes enough ignition points to create cascading effects. Cities with dense infrastructure would be especially vulnerable. Power grids fail. Transportation systems get disrupted, emergency response systems are stretched beyond capacity, and all of this is happening while the clock is ticking, because this only lasts 5 minutes, which sounds like good news, until you realize 5 minutes is a long time for uncontrolled fire. Now let's talk about what happens when the oxygen suddenly drops back to normal. At exactly 5 minutes, the atmosphere returns to 21%. The air stabilizes, new fires become harder to start. Combustion slows back down, but the damage doesn't just reset. because anything that caught fire in those 5 minutes is still burning. Cities don't instantly recover. Forests don't unburn themselves. Smoke fills the atmosphere. Air quality drops. And now we're dealing with the aftermath. Fires continue for hours, days, weeks in some areas. The initial 5-minute event becomes a long-term disaster. Now here's a deeper question. What would cause oxygen to double in the first place? Because Earth doesn't just casually change its atmospheric composition. Oxygen levels are tightly regulated by biological and geological processes. Photosynthesis, respiration, chemical reactions with rocks and oceans. For oxygen to double instantly, something massive would have to interfere with that balance. And if something can do that once, it might be able to do it again. So the real danger isn't just the 5 minutes. It's the possibility that it wasn't a one-time event. Because if the atmosphere can spike like that, then stability, the thing life depends on most, is no longer guaranteed. So to answer Marcus's question, for a few seconds it might feel like a breath of fresh air. For a few minutes it would turn parts of the planet into a firestorm. And long after those 5 minutes are over, the consequences would still be burning. Literally. And in a system where balance is everything, even a temporary change can leave permanent scars.